Hey guys, so today we're going to be talking about different ways the periodic table are organized. Specifically, we're going to be looking at metals, nonmetals, and metalloids, and the different families and groups that you guys have been learning about. So one way to classify elements is to broadly classify them as either a metal, a nonmetal, or a metalloid, depending on their physical and chemical properties. As you move left to right across the periodic table, you're going to go from being more metallic on the left side to less metallic on the right side, and less non-metallic on the left side, and more non-metallic on the right side. So we lose the metal properties as we go across the periodic table, again, left to right. So most elements on the periodic table are considered metals. It's about 80% of all elements are classified as a metal. And some characteristics of metals are that they're good conductors. So they're good conductors of both heat and electricity. So you probably remember learning about conductors in 8th grade, and again, that allows a current to run through it for it to be considered a conductor. So anything that's a wire that you're using in your house to get electricity is a conductor and is a metal. Okay, a metal that has just been cut is going to have high sheen or high luster, so it's going to be really shiny and you're going to be able to see reflection in it. At room temperature, metals are solids, except the one exception is going to be mercury, which is a liquid at room temperature. Otherwise, all metals are solids. Most metals are malleable, which means they can be pounded into a thin sheet. So metals are also ductile, which means they can be pulled into a very thin wire. You can also classify elements as a nonmetal, and these are all going to be on the right side of the periodic table. And again, we always have exceptions, and the only exception here is hydrogen, which is on the left side of the periodic table. So they can only be found on the right, except for hydrogen, which is on the left side of the periodic table. So there's more variety of physical properties among nonmetals compared to metals, but in general, they are mainly gases at room temperature. Some are going to be solids, and that's going to be something like sulfur or phosphorus, and some can even be a liquid, which is bromine. So again, unlike metals, which we could all classify as being a solid, except for mercury, we are going to have a greater variety within those nonmetals. So it is kind of hard to describe general properties for nonmetals, again, compared to metals, which have very similar properties. But for nonmetals in general, they usually have the properties that are opposite of metals. So if we know a metal is malleable, we can then assume that nonmetals are going to be non-malleable. In general, nonmetals are poor conductors of heat and electric currents. Again, there's exceptions. One exception is carbon. When it is in the form of graphite, that is actually a good conductor. Nonmetals also tend to be brittle, which means that if you hit them, they will easily shatter and break apart. Lastly, we have metalloids, and they kind of make up that stair step on the periodic table. You're going to see that when we color it in class today. But in general, metalloids have properties of both metals and nonmetals, and depending on the current conditions of where that element is will determine the properties it is showing. Okay, so now we're going to look at classifying the elements based off of their groups, also known as families. So the first group we're going to look at are the alkali metals, and they are group 1, so they are the furthest to the left. As you can guess, they are a metal, and all alkali metals, their electron configuration ends in S1. Alkali metals are also highly reactive, have low melting points, and are considered a soft metal, so that means that I could actually use a knife and I can actually cut through an alkali metal. Our next group we're going to look at are the alkaline earth metals, and they are in group 2, so they're that second column, and they will end for their electron configuration as S2. So alkaline earth metals are also reactive, but they are not as reactive as the alkali metals. Our next section is the transition metals, and they are groups 3 through group 12, and they are all characterized by having D electrons and F electrons. So all of them do have D electrons, and the bottom 2 rows have F electrons. The next family we're going to talk about are the halogens, and the halogens electron configurations have the highest energy electrons ending in S2p5. Halogens can also form diatomic molecules, not all of them, but some of them, so it means that they bond with themselves. So an example would be F2, which is 2 fluorines that have been bonded together. Halogens are also highly reactive, so they are our highly reactive nonmetals. Then the last family we're going to talk about are the noble gases, and the noble gases are group 18, aka the furthest to the right column, and they'll end in S2P6. Some characteristics of noble gases are they are colorless, they are generally odorless, they're generally a gas, and they are very stable. So the reason they are so stable is because of that end of their electron configuration. You'll notice they all end in S2P6, and that's because they have a full valence shell. So they have full valence electrons. That means that their S and their P suborbitals are completely full.